All right, let's continue the second parts of chapter 6.2. Now, what I'd like to do is go through a bunch of questions to read and apply the table. Now, let's say you want to figure out P of Z, say less than equal to 1.42. Now, what do you think this question is asking? Look at this. This is a probability that Z. What's Z? Z is the standard normal distribution. It's going to be less than or equal to 1.42. Now, whenever that you try this type of question, I want you to draw a small graph like that, and then try to figure out what this question is asking. It's asking this. This is a Z distribution, and the middle value is 0. 1.42, let's say it's about here, 1.42, and you want the probability that Z is going to be less than this. So they talk about this area. So how do you find this? Well, you can find this using the Z table. Now, what you are looking at is the Z table. Now, as you can see, this part right here, the middle part is the Z number. It's the area, and these are the Z number, right? And these middle part is the area, the shaded region right there. So if you want any Z value to the left, the shaded area, and this is the portion. Now, what was our score? 1.42, right? 1.42. So I'm looking at 1.42. Now, as you can see, 1.4 is right here, right? Can you see that? 1.4? Yes. 1.42 should be this number. See that? That's 0.02. So up to 1.4 that you read it from here, and 1.42 that you match this line, and that's what? 9.9222. 0.922. So if you go back to that board, according to the table, that proportion right here, it's going to be how much? That's going to be 0.9222. So what should be the answer? Answer should be 0.9222. That's the answer, and that's how you read from the table. Now let's do one more. Let's say you want the probability that's between 1.00 to say 1.53. Remember, whenever that you do something like this, I want you to draw a small graph, looks like this, and try to figure out what area that you are looking at. So let's say 1 should be about here, 1.00. Say between that, let's say this point is 1.53. So you're looking at this area. So how do we find this area? How do you find this area? Well, what you do is you find 1.53 to the left first, the whole area right here, and then from that you find 1.00 to the left. You find this area and you take it out. So from the whole thing, if you take out this, then you're left with this area, right? So let's find how much would that be. 1.53 to the left. Now go to that table, 1.53. 1.53 should be this number right there. See that number, 1.53? So 0.9370, right? So this would be 0.9370. Now to that, we're going to subtract this much, right? 1.00 to the left. Now, if you go to that table, 1.00 is right here, right? This number, 0.8413, right? 0.8413. So this would be 0.8413, right? That would be that area that we are looking for, the area in the middle. So if you just type it up in your calculator, then answer should be 0.0957. That's the answer for this. That's the answer for this, right? Okay, now let's do a couple of more. Let's say this time you want that, let me just readjust it a little bit. Okay, that's good. Let's say you want the probability that it's going to be, z is going to be bigger than 2.1, all right. Again, I want you to draw a small graph. You know it's going to be 0 there. Say 2.15 is here. You want the z value is going to be bigger than this number. That means it's going to be here. That means it's going to be here. But as you probably know or noticed, the table doesn't give you area to the left. I mean to the right. It only gives you area to the left. So if you read this number from the table, it'll give you this area, not that area that we're looking for. But we also know that total area is going to be 1. So if you do 1 minus of that area, that will give us this area that we're looking for, right? So 1 minus of this area. So how do we find 2.15? If you go to that table again, say 2.15 should be this number right there, right? 2.15. 0.9842, right? 0.9842. So 0.9842, right? So if you do 1 minus of that, let me see, minus 0.9842, then our answer is going to be 0.0158. That should be our answer, right? So if you keep practicing these questions, then you should be able to figure out the area to the left or area in between, area to the right, and all kinds of those types, right? Okay, now let's go back to our PowerPoint, right? Let's go back to our PowerPoint. Let's try this question. So this question says, this prep zone sales auto part and supply, including this popular brand of motor oil. And when the stock of this oil dropped to 20 gallons, then they order a little bit more, right? The store manager is concerned that the sales are being lost due to the lack of stock, right? So it has been determined by a demand during this time. The lead time is normally distributed with a mean of 15 gallons and the standard deviation of 6 gallons. And the manager would like to know the probability of stock out during this lead time, and in other words, what would be the probability the demand during this time will exceed, which is more than 20 gallons. So they basically want this. What would be the probability of X being bigger than 20? All right, bigger than 20. When the 15 gallons is the mean, the standard deviation is 6 gallons. Now, let's check out this. Let's check out this. So if we have to graph this situation, what would that look like? The middle value was 15. How do I know? Because they say the mean was 15. What's the standard deviation? So this should be mu value. Standard deviation is 6. That's what this says. And I guess 20 should be about here. Let's say 20 is there. And we want the probability of X being bigger than 20. Meaning what? They want this proportion. They want this proportion. Now, if this is, and this is a X distribution, the usual, normal, standard, just the normal distribution. Now, you want to convert this. You want to convert this into the Z situation, right? You want to convert this into the Z situation. Well, if it's a Z situation, then what's different? Well, if it's a Z, then you know that the middle point is going to be 0 and standard deviation is going to be 1, and that point 20 is going to be some number right there, and you want to figure out this proportion, right? But you don't know it yet. You don't know which point is that going to be yet. So how do you convert your X to Z, the corresponding Z value for X? Well, you use that formula, Z equal X minus mu over sigma. But isn't that what PowerPoint says, right? If you go back to the PowerPoint, right, page 14, you can get your Z using that formula right there, right? So you will not be able to figure out this probability, but if you convert this into Z, right, that formula, X, which is 20, minus 15, which is mu, divided by 6 is 0.83. Now if you convert that, then your Z is become 1.83, 1.83, right? I mean, no, 0.83, 0.83. Now, if we go back to that drawing board, now we know what this is going to be. This is going to be 0.83, and we want the left of it. So we want the PZ greater than 0.83. Now, as we checked before, the table will give us this proportion, right? This proportion. So if you find 1 minus of that proportion, then we get that proportion, right? So 0.83, if you look it up in the table, 0.83, then that's the number, right? 0.7967. So if you do 1 minus of 7967, there you go. This is your proportion. See that shaded area right there is going to be 0.2033. Which means what? Which means you have like 20% chance that it's going to be more than what? This was the original question. That it will exceed 20 gallons. How many percent chance? You have 20% chance, right? Now, this is relatively confusing concept. So I want you to watch this video as many times as you need until you actually understand, and pause as many times as you need while you're watching this video and recheck yourself, right? Okay. Now, so next question is, if the manager of this prep zone wants the probability of stock out during this reshipment time to be no more than 5%, right? 0.5, that means 5%. Now, if it's currently, if you want, previous example, let's say going back to here, what's the probability that it'll be exceeding 20 gallons? Probability at the end was about 20%, right? 20%. Now, this time, manager wants no more than 5%. Then if you actually think about this, manager wants your point should be right here, so that above you 5%, behind you 95%. You want that number. Now, you would not know if it's 30 gallons or 40 gallons. You wouldn't know. You know that it's a 20 gallons, that was about 20%, right, from the previous example, but you wouldn't know. That's why you want to find the z-value first and convert the z-value into x again, because you wouldn't know that this is 20 gallons or 50 gallons, whatever, but for z-value, that you know what z-value that this should be in order to have 5% above you, 95% behind you. Now, if you go back to this table, and this is the portion that you need to know. If you want 95% in here, meaning you want the z-value, which will give to the left as 95%. So you want that z-value. Now, going back to this table, you're backtracking. From the middle portion, you want the 95, because 95 then means whatever the z-value to the left is going to be 95. Well, apparently it's actually right in between these two values, right? Right in between. So 1.6 between 4 and 5. So that z-value is going to be 1.645. 1.645. And they have this. Now let me go to that smooth draw again and explain where they get this. Now remember that conversion formula, that z was x minus mu over sigma. Now the current question, that we know this z, this was what? 1.645. But you don't know this. You don't know this. When you have mu as what? As 15. Sigma as what? 6. That was the given, right? Given point. You want to find the x. In other words, if I rewrite this, 1.645 equal x minus 15 over 6. And you want to know the x. And I guess we can do this, right? You multiply, say, 6 on both sides. So if you multiply 6, then this 6 and this 6 cancels out, right? If I just switch the left and right side, then it would be x minus 15 would be 6 times 1.645. Then if you add 15 on both sides, x is going to be 15 plus 6 times 1.645, right? And let's go back to the PowerPoint, and that's what they have right there, right? That's what they have right there. So if you find that x, that becomes 24.87, or approximately 25 gallons, right? So if you have like 25 gallons, then you have less than 5% of the stock out, the lead time. If you have like 20 gallons in reserve, then you have 20% chance that you will have the lead time. If you have 25 gallons in reserve in stock, then you have less than 5 chance that you will have the lead time, right? Okay. So, if let's compare that page 22, right? That's z value. That was 1.645, 5% right there. Now you convert that to our usual x situation. Then you have 15 there, 24.87. Then 5% is going to be there, right? Okay, so so by raising the reordered point of 20 gallons to 25 gallons on hand, the probability of the stock out decreased from 20% to 5%, right? Okay. All right, so this is substantial question. I want you to study this same question many times until you feel very comfortable. Then you can try these homework questions. Now, as you know, that our final is going to be December 12th, right? So if you have any questions regarding the final exams or any question that we tried so far, don't hesitate to contact me, right? You can email me and we can do a Google Hangout sessions, or we can have any type of meeting, right? And please do try all those previous homeworks before the due date, right? Before the final due date. All right. Then I'll see you on December 12th, or before that, maybe can see each other through online or the Google Hangout. All right. Okay.